In this video, let us see about chelate effect. It is very important in coordination compounds. Chelate effect increases the stability of the complex. What happens? What is meant by chelate effect? If you observe, the increase in the stability of the complex when a metal is bound to a bidentate or polydentate ligand is called as chelate effect. The increasing the stability of the complex takes place. Okay, for example, if you observe this bidentate ligands or polydentate ligand like ethylene diamine tetrastate, okay, it is tetradentate with 4 donor atoms. For example, if you see this bidentate ligands, it is ethylene diamine. It is bounded to this metal ion, whereas here it is propylene diamine. Okay, the increase is called as. Here, for example, a complex is there. In this complex, if you observe this one, that is cobalt is bonded to ethylene diamine. 3 moles of ethylene diamine is there. Whereas if you take up this one, CO, instead of ethylene diamine, if you take 6 ammonia molecules, say 6 ammonia molecules, which is more stable. Okay, this is said to be more stable than this complex. What is the reason for this one? Here, what happens means when this complex, for example, CONH3, in order to form this complex, COH2O, in the beginning it is the hydrated form, let us assume, plus 6 ammonia molecules. 6 ammonia molecules are bounded to this one. When it is bound, it forms a complex. Why? Because H2O are substituted by ammonia. NH3 taken 6 times plus 6 H2O molecules. The number of molecules before the formation of the complex are 7 molecules are combining to form again 7. There are no change in the number of molecules. Whereas if you observe this one, the same COH2O taken 6 times, H2O taken 6 times, that is hexa aqua cobalt we are taking. Okay, the charge will be there. It is bounded to ethylene diamine. What is ethylene diamine? Just now we had discussed about ethylene diamine. It is a bidentate ligand. Okay, that is, it is a 3 moles of this one ethylene diamine are bounded to this one, COEN tris. It is called a tris. Tris ethylene diamine cobalt plus 6 H2O molecules are formed. Okay, if you take the charge also, okay, it is ethylene diamine, and here if you observe the charge, here the number of molecules are 1 molecule plus 3 molecules, means the reactants are 4. Okay, the reactants are 4 here. The reactants are 4. Whereas here the reactants, the number of reactants are that is 1 plus 6. This is 6. Therefore, 1 plus 6 means 7. 4 is converted into 7, means there is an increase in the disorderness. Okay, according to the thermodynamics, first law of thermodynamics or second law of thermodynamics says that whichever system increases the disorderness, that is entropy is increased, it is said to be more stable and is occurring spontaneously. Therefore, this is more spontaneous than this one. Okay, that is why we can say that as there is an increase in the entropy of this complex, it is going to form a stable complex. Therefore, it is forming the formation of rings. If you observe this complex here, this complex is having rings here. Okay, the formation of rings are there. This is a ring. This is a big ring is there. Here one ring is there. The formation of rings increases the stability of the complex. Okay, that is here the hydration sphere is completely dispersed. In the beginning, this complex is having a number of H2O molecules. This is a hydration sphere is completely disturbed here. Okay, that is about here we can explain the same thing by using thermodynamics parameters of thermodynamics. For example, here in thermodynamics, we know that delta G is equal to delta H minus T delta S. Delta S minus T delta S. We know this one. Okay, therefore here we know that what is delta G? Delta G is nothing but entropy change. Sorry, Gibbs free energy change. Delta H is enthalpy change. Delta S is entropy change. We know another equation, that is delta G is equal to minus log beta into RT, otherwise RT ln beta. It is nothing but RT. You can write it as RT ln beta. Okay, that is RT ln beta is there. Here we can write here it as delta G is equal to minus RT ln beta. What is RT? RT is nothing but R is nothing but universal gas constant. T is absolute temperature. Beta is nothing but chemical equilibrium constant or equilibrium constant. Okay, therefore here once you know if your log beta is increased, delta H G is increased. Automatically once delta G is increased, entropy is also increased here. The delta H is negative. Therefore, here log beta is increasing. Let us see, for example, in this complex CuH2O copper complex we are taking, that is hexaamine copper NH3 taken 6 times. This is the complex hexaamine copper 2 ion. Another complex is copper ethylene diamine. It is bonded to ethylene diamine. Okay, that is, it is bounded to ethylene diamine. That is ethylene diamine taken 3 times. Tris. Again, the charge does not change. Plus 2, 2 plus. Whereas another complex is triene. It is a tridentate. Triene. Triene. It is tridentate, therefore 2. Again, it is charge is plus 2. 2 plus. That is a 2 plus charge. If you observe the log beta values, it is found that log beta of this one is this complex is found to be 12.7. Log beta is 12.7, whereas the log beta value of this one is 19.7, and the log beta value of this one is 20.5. Which is greater? The log beta value of this one is greater than that of this one. Okay, as there is minus charge here, log beta increases, delta G also that is going to increase. Minus, if delta G is minus, then only it is said to be spontaneous. Delta G will be minus automatically if log beta increases. Therefore, we can say that log beta increases, delta S also increases. This is also one of the parameters. Thus, we can say that as the chelation, that is the formation of rings, increases, the stability increases because there is an increase in the, that is entropy also during formation. Okay, for example, if you take up this one, that is ethylene diamine tetrastate, ethylene, it is ethylene diamine. Here diamine is 2 nitrogen atoms are there. Tetrastate, this is very important ligand. Okay, that is C double bond O, used mostly even in foods also to increase the preservative. It is used as a preservative so that it binds with metal ions and increases the shelf life of the food. Ethylene diamine tetrastate. It is used as to remove the ions also from, for example, arsenic, mercury, certain heavy ions also can be easily removed. by using this EDTA by means of an effect known as chelate effect. Chelation effect is used. Okay, why, how it is going to be formed? Okay, that is because it readily forms mainly because of the formation of this chelation effect. It is possible only because of chelation effect it is possible. Okay, chelation effect only it is possible. CH2 missing. CH2 and here also CH2 is there. COO minus. This is ethylene EDTA. Structure of EDTA is this one. Okay, that is if you observe this one. This is ethylene diamine tetraacetate is very important complex. Once it is going to form a complex, okay, that is CH2 COO minus, COO minus. This is ethylene diamine tetraacetate. Metal ion is going to bond with this oxygen atom and this oxygen atom and this oxygen atom. There are 4 chances are there, and this oxygen atom. Okay, all these will be bounded to this metal. As a result, it is going to form. Okay, a biggest ring is formed. Big ring is formed and increases the stability of the complex. Even if at all a bond is broken, this bond will be automatically bound again because of the high stability. It is reformed. Okay, the bond that is broken is again formed easily by this one. Okay, it is easily formed again. Why? Because of the high stability of the complex, it is possible. Even in biological systems also, macrocyclic systems, chelation effect is studied in the name of macrocyclic systems. What we have learned is, in this video is, chelate effect increases the stability of the complex because of the formation of rings. Why these rings are going to increase the stability? During the formation, for example, in the aqua complex, water molecules are replaced by bidentate or polydentate ligands. The randomness, entropy is increased. According to the second law of thermodynamics, whichever increases the disorderness or entropy, they are more spontaneous. Therefore, they occur spontaneously. We can explain this one by using log beta values also. The log beta values are increased as the chelation or the formation of rings are increased by bidentate and polydentate ligands. Then we had learned in this video what are chelating ligands, what are chelate rings, how the chelate effect is increased by the help of thermodynamics. Thank you for watching my video.